Example 4. Determine the size of the monthly deposit needed to accumulate $150,000 in 4 years if the deposits earn 10% compounded semi-annually. Once again, the first thing you should notice is that there are monthly deposits and a semi-annual interest rate. So we've got a semi-annual rate and monthly deposits. We've got a general annuity. However, we do know that we wish to accumulate $150,000 in 4 years, and so that's going to represent the final accumulated value of our deposits. So let's see, with our time diagram, we're going to have our annuity payment. So we've got a total of, let's see now, 4 years monthly deposits. That would be 4 times 12, or 48 monthly deposits of R dollars, or PMT, or payment size. I'll use R dollars for sake of simplicity. 48 monthly deposits of R dollars. And we have an annuity here of 48 monthly deposits. N is equal to 48 deposits. And we also know that the final value, the maturity value, is equal to $150,000. That's our target. Our target is to accumulate that much money in the 4 years. The interest rate is 10% compounded semi-annually. I happen to know that the formula for the final value says that the final value of $150,000 is equal to R dollars per month multiplied by the annuity factor 1 plus I per month. Power is positive 48 because it's a future value and it's accumulated with the payments plus the interest, minus 1 divided by the interest rate per month. And so now what I need to do is to step aside and convert from 10% compounded semi-annually to the equivalent rate per month so that I can use the formula to solve for the payment size. And so doing the side calculation, we've got to go from 10% compounded semi-annually to the rate per month. So I can use the annuity formula. So 10% compounded semi-annually, if there's 2 semi-annual periods in a year, I'm going to divide by 2. That's going to give me 10% divided by 2, or 5%. 5% per 6 months. Now I still need to find the rate per month. What is that equivalent to? So I'm going to take this 5% per 6 months. That's 1.05, and in 1 year the semi-annual rate will have compounded twice, and that will equal my 1 plus rate per month, 1 plus I per month, compounded in 1 year. A monthly rate will have compounded 12 times. So now what I'm going to do is to solve this equation, the equivalency for I, the rate per month. And I'm going to do that by raising both sides to the reciprocal power and on the I variable. So we're going to raise both sides to the 1/12th power. So raise the left side and the right side to the 1/12th power, and we'll end up with 1.05 to the power of 1/6 is equal to 1 plus I to the power of 1. We multiply the exponents when we raise a power to a power. So we'll end up with an equation that says 1.008168 and so on is equal to 1 plus I. Store that in memory too, and of course we're going to need to subtract 1 to get the rate per month, and so I is going to equal 0.00816 and so on per month. And we're going to store that in memory 1 so that we can have a I interest rate in memory 1 and 1 plus I in memory 2. And so now that we have the interest rate stored in our memory, we can now substitute back into this equation and say $150,000 is equal to R dollars multiplied by the factor 1.00816 and so on. Power is positive 48. Take away 1 divided by 0.00816 and so on. And so we'll work out what the factor is. Recall memory 2 raised to the power of 48, subtract 1, hit the equal bar, divide by recall memory 1, hit the equal bar. This will be your annuity factor. Then we're going to divide that annuity factor into the $150,000 to solve for the payment size. And so the payment size works out to $25.65 and 11 cents. $25.65 and 11 cents. And this is the deposit that is required per month in order to accumulate $150,000 in 4 years. And as an additional comment, in order to use the financial calculator, the BA2 Plus calculator, or whatever calculator you're using, again, what we'll do is we'll initiate the calculations by noting that the present value is 0 and the future value is $150,000. So we start out with nothing and we accumulate a final value of 150K. So we'll enter that into our calculator. So put 0 into the present value, or 0 is equal to PV, and 100 plus $150,000 is equal to the FV. Now we'll enter in the number of payments. The number of deposits is 48, so 48 is going to be entered into N, and the interest rate that is given to us is 10% compounded semi-annually, so we will enter in 10 into I/Y. We'll go second function IY to enter the other details, and second IY will take us to the PY. Payments per year is 12, so we'll enter in 12 for PY and make sure that we press the enter key, hit the down arrow button to go down to compounding periods per year, or CY. That's 2 because there are 2 semi-annual periods per year, so we're going to put 2 in and enter, and second quit to get out. Now we're ready to compute the payment, and we will compute the payment, and the payment will be negative $25.65 and the reason why the payment is negative is because it's going to be used to offset the future value. So we're out of pocket by $25.65 and at the end of the 4th year, or after 48 deposits, we'll have plus $150,000 to show for it.